Our first speaker today is Eyal Amir, and he's an audio C++ developer, and he's going to talk about CMake for the uninitiated. And I'm really excited about that topic because I think pretty much every software project I've been involved in uses CMake. And it's kind of just ubiquitous in the industry. And it's one of those things that you kind of should know or have to know or are like really useful to know, but it's not really taught properly anywhere, or like at least I haven't really seen it being taught very much. And so it's kind of one of these things that you kind of have to magically acquire yourself, like, and teach yourself how to do it, which is kind of a rocky road. So I'm really, really happy that Eyal is here to, introduce us, to give us a little bit of a gentle introduction to CMake. And I think it's going to be super cool talk, and I'm really looking forward to it. So Eyal, over to you.
Thank you, Timur, and thank you, Josh and Rachel. It's great to be here with you. All right, so I've started with a few slides. This is my first time ever actually making slides for something, so hopefully you'll find them reasonable. Let me share my screen. Okay, so this is my talk on CMake. So who am I, right? I'm a C++ audio software engineer. Some of my past stuff is Waves. I've made a bunch of plugins for Waves, X for Records, Deadmau5, Polyverse, Pitch Innovations, Artlist, and a bunch of other companies that I worked on commercial projects. I just started my new plugin company named Modalix with my partner Or Lubianico. And I'm also a musician, composer, keyboard player. You can look up my name somewhere and you'll find all kinds of weird progressive rock music. Also, I'm not a CMake expert. So I'm a pragmatic user of CMake. Hopefully I have some of the concepts understood well enough to help people get along with their journey. But to be honest, a lot of the stuff I've learned from people with more experience than me, like Ruben from the JUCE team, Alain Martin from Ableton, on some people even on our audio programmer Discord, like Bacon Paul, even Ilanda, like users who have more experience either on writing CMake code or configuring build systems and so on. So, but I do like workflow improvements. So I like all kinds of things that make your environment more solid, easier to reason about, or enable more features, etc. Okay, so what is CMake? It's a cross-platform meta build system. And it's the de facto standard to build C code. So if you get a random library, random C or C++ library from GitHub, there's a very good chance it will already use CMake. And that's true in a lot of different fields. It's also a rather basic scripting language, so you can write some sort of code in it, if statements, for loops, etc. So before we talk about what a meta build system is, we need to talk about what a build system is. First of all, you need to compile each source file, right? You got a bunch of C or C++. I got someone knocking on my door. 1 second.
Yeah, this is one of those
that had to be the funniest thing that could have happened. My neighbor knocking on my door.
Well, this okay? Also, this is a good opportunity for me to say to people, if you have a question, please precede those in the chat with the word question. So all in caps so we can see them clearly. But please feel free to ask any questions, no matter how beginner or advanced they may be. And I'm sure Eyal will know the answer.
Hopefully.
All right, okay. Please.
Sorry about this pause. So you got to compile a bunch of source files, called the compiler for each of those. Then you got to link the object files that are created into a finished binary, like your app, plugin, whatever. that's it, right? Simple. We can all go home. This was hopefully a very productive session for everybody. But actually, there's a few other stuff. So you got to set optional compile flags. Like maybe you have a logger that sometimes gets built and sometimes isn't. And maybe you have different flags if you have a different type of audio plugin or different type of app. So the build system has to somehow pass that along. Maybe you have a Mac app and you got to build a bundle to put all the files together. You got to copy something like a plugin into the correct system folders. You got to maybe generate code if you have a step from like another language that has to run before the C++ code. You might want to generate binary resources, like the binary data on a plugin, images, fonts, audio files, other things that the code needs access to. You might run pre-built scripts, post-built scripts, code signing. So this is a bunch of stuff, and this is just the stuff in your code. So usually there's also a bunch of other code that you have to build, like a library, if you're using JUCE or Qt or some other library that somehow gets linked to your project. That also needs everything that I've just said. And a lot of people ask, isn't my IDE already taking care of that, right? If you're using Visual Studio or Xcode, like those things are there. Like you can drag files into the IDE and it will know how to build them, and you have a settings page. And it does work, but as you know, if you've ever done it, it only works on a single platform. So Xcode will only work on Mac, Visual Studio will only work on Windows, etc. And it also forces everybody else to use the same IDE. I've worked at companies where, for example, the Windows project is a Visual Studio project, and it's very limiting because some people want to use something else. But then you're forcing basically everybody to add it the same way, even if they just want to build the code. It's also harder to share configurations. So you'll see that something that happens in bigger project is you might want to have a centralized way to do certain things so that all your projects do the same thing. That's very important when you're in a bigger company and there's a bunch of apps or plugins or something. You don't want to have each thing configured separately. And that's something that's harder to do in an IDE. Even though IDEs do have that feature, it's not the most convenient thing to just bring in some configuration. So some of the people here are using something like JUCE, and you're familiar with a tool called the producer. And you're asking, isn't the producer doing this for me, right? Because it does generate, Visual Studio projects, Xcode projects, make files on Linux and stuff. So the problem is it only supports a specific set of IDEs. For example, when I started to use JUCE, I wanted to use CLion, and it wasn't supported. But then later, as support was added, it wasn't complete. And then I later wanted to use something like Visual Studio Code, which is a very popular editor, and it wasn't supported. So I had to wait for that support to be there. And it's, I guess, hard for somebody like the JUCE team or any kind of a library development team really to support everything else. It also doesn't allow to share configurations between projects. Like sometimes I had to update all my projects to add a little thing because I needed a new flag, and then it needed to be added everywhere. And it was pretty hard to remember where it needs to be and where it doesn't have to be. And also more advanced build configurations are either hard or just plain impossible because it only supports a very specific way of doing things. So CMake to the rescue. It's cross-platform. It runs on almost every platform that C or C++ can work on, even mobile, Linux, etc. Supports all the major IDEs. Either you export to them or they just already know CMake and they can open it natively. Can be configured or built through the command line, which is useful if you have like an automated build system. Supports text editors like VS Code. And the most important bit for me, which we'll probably go over a lot in the live demo, is that allows to have the concept of dry, don't repeat yourself, in the build configuration. Okay, so let me switch over here to my to the demo thing. And now we're going to start seeing some cool stuff. So I'm going to use CLAN quite a lot, but I'll also use a few other things just for the demo. CLAN is specifically my favorite IDE to use, also because it supports CMake natively, even though there's other reasons. So, so let's start with the hello world thing. Yep, there you go. Great. Hopefully this is clear enough. How do I zoom this? Okay, hopefully this is bigger. So, so this is like the most basic project you can do in CMake. You have to declare the version of CMake that you want to be using. You want to declare the name of the project, the C++ standard, and then you add some target as an executable, and you give it source files. This is pretty obvious, hopefully, and pretty much the basics that you think about in any kind of a build system. And you can just build it and it will work. And so you can also like generate something. So if I go to my terminal here, I can do something like, hopefully this is big enough. So I can do something like CMake -g xcode -b build. And that will generate, oh, not build, let's use another build directory. So build xcode. And this will start generating a project for my favorite IDE, like xcode in this case. So it takes a few seconds, it generates it, and then right here I will have a build xcode folder, and there will be a hello world xcode project in there. And the same thing can work if you're using Windows. You can do something like, I don't have Windows right now, but you can do something like Visual Studio 16 2019 and get a Visual Studio project, etc. So this is a very simple way to just get going no matter what your IDE is. And stuff, if you're using something like Visual Studio Code, it's a big favorite of mine. So Visual Studio Code allows you to just drag like the folder in there if you have these extensions. So you need something like the C++ extension, the CMake extension, and the CMake tools extensions. And then it will also allow you to do something like tap meetup, hello world, and just drag the folder in there. And if you have a CMake file in there, it should automatically configure that and just allow you to build, right? You see it automatically discovers all the targets in there and runs hello world. Usually it also will pick up like everything in the code, and you can just browse and debug and work like you do in any other IDE. So that's a really nice bonus. So let's look at something more advanced. So let me close this project and let me open another project called app with shared library. So this is like my next step usually is, I don't just write an app. I have some library that I wrote that I want to share code with. So what I did here is I did something called add subdirectory. So I connected another directory. In CMake, a directory is just any directory that has a CMake lists.txt file, which is where we describe the build process. So I can do something like add subdirectory and add shared code, right? And shared code is just another simple folder that has, hopefully this will be visible enough. Let me get this down. So what this does is it adds the library as a static library with the source, sharedcode.cpp. And then it has the include directories because usually, we have to have some way for the user of the library to find the files, to find the source file so that it can include them. So our main project will just do something like add subdirectory, right? So first it knows about this library, the static library. Then it adds the executable, and then it links them together. And if you look at the code, right, the shared code has one amazing function. It's called hello world from lib. Here you can see the amazing implementation of this function. And in main, like in our app, all we have to do is include this, which is now in our include directories. So that was passed to us by the library, and then we could just build, right? So that we'll build, find the library, build the library, and call hello world. So far we're in like the most obvious basics to just build C++ code. But let's do something more advanced, right? So usually you don't just use your own code, you use other people's code, like libraries. And a big question is, how do you even get the libraries? Do you use like the system package manager? Do you copy them into your repository? Do you use a Git submodule? There's a bunch of ways, but I will show like one of my favorite ways to do this. So I have this thing here called CPP CMake Starter, just a folder that I have. And this is like a template I made for myself so that I will immediately have some dependency, because I know that just setting up a dependency is complicated. And in this case, the dependency is a really good HTTP library, right? That allows you to write really simple HTTP clients or send messages and servers. So to use this, I've used a really nice CMake script or CMake library that's available for free called cpm.cmake. And what it does is you can declare these dependencies and where they're from. So you'll see that it says that add this package, right, from GitHub, right? So it will actually go to GitHub as a part of the build process to branch master, grab this library, and configure it already automatically for me because it's already using CMake. So when I run this and CMake configures it, it will do something like you can see in the configuration log. It says adding package cpp http lib. So I didn't have to go to this. I didn't have to call any extra command. I just called CMake -g whatever, and it ran this as a part of the script. And this is really useful actually, because then you have a very easily reproducible environment if you have other dependencies in there. And so that's all I needed to do to configure this. And in my code, so I have all I had to do is include HTTP lib in there, right? You can see I didn't have to know even where it is because I think the CMake file already configured the include directory for me. So once I did something like target linked libraries, my app with HTTP lib, HTTP lib knew to pass in the folders of where it is. So it just says find HTTP lib, and the compile system or the build system knows how to resolve that. So in this case, I'm just sending an HTTP message to get google.com, and this is what google.com looks like. I don't know if you ever went to it, but obviously everybody knows that this is the usual output you're expecting. So I like to start like this because usually I will, when I start out, I will bring in a bunch of stuff. Maybe I will bring in JUCE. Maybe I'll bring in, I don't know, Boost. Maybe I'll bring in a unit test system or unit test framework, which we're going to talk about in a second. So this is really my kind of my first steps, right? Make the project build, make your app. In a second, we're going to talk about like audio plugins and stuff like that, and how it works with that. But before that, do you want to stop and ask me like some question before I run on?
So I don't think you actually have questions yet on the chat, but I'm very happy that you're using CLion because that's my favorite IDE too. And supports CMake natively. So you just open it and it just works, which is pretty cool.
Yep.
And it works on Windows, Mac, Linux. So that's kind of what I use as well. But yeah, there are no questions yet. But if you have any, please feel free to post them on the YouTube chat and I will ask Eyal those questions.
Great. Okay, so let's go. So now that we've talked about the basics, to me, like it's, I guess this part, like fetching the thing from Git, is not as basic. But let's go deeper now to how we configure audio apps. So starting JUCE 6, JUCE started to support CMake natively, which I thought was amazing. I was so happy they added that. And I have a repository that's publicly available on GitHub with some configuration starters for JUCE, because JUCE introduces a few things, well, not just JUCE, but plugins introduce a few things that aren't as straightforward. So let me load that. And this is a more complicated CMake file already. There's other things that we have not talked about yet, but let's go through some of these, and see if we can kind of extract what this does. But the first thing you'll see when I loaded this is that there's a bunch of plugins that gets loaded in as targets. So this loads see I have a MIDI effects template. I have just a minimal plugin template. I have a plugin template with a custom module. I have the unit test runner. So it builds a bunch of targets. And that's one other thing that CMake can do that other build systems don't always know how to do, is there's multiple things connected to the same project. Sometimes they get built together, and sometimes they're just a convenience or something that the developer needs, like the unit tests. So something that you want to have around with you inside of your development projects, right? So you don't want to open a new Xcode project or Visual Studio just so you can do the unit tests. That would be annoying. So these are a few things that have more been things that I tested when doing plugins. So for example, you'll see there's stuff like the minimum Mac OS target in here. There's a flag that you can pass in whenever you're building universal binaries that will support M1 and Intel on Macs. This is a Windows configuration that has to do with static or dynamic linking. These have to do with how the source folders show up when you open an Xcode project. And here, that's the interesting bit. This is where I bring in JUCE, right? So I've connected my project to this version of JUCE, and it will just go to GitHub automatically, fetch that into the build directory, so into a temporary directory inside my project. So I don't have to do anything to have JUCE. If anybody grabs this, you don't need to have JUCE. It will get it for you. And there are ways to configure that, which I will go over in a second. So so you add this, and then you add other directories like apps, plugins, and unit tests. So so let's go over a few of other things that this thing has allowed me to do. One thing is stuff like code sharing. So for example, I wanted to have that my examples have a really clean, minimal interface, right? So for example, the minimal plugin templates, this is the entire code for the minimal plugin templates, or the header. It's something that inherits from this base class that came out of nowhere, it seems. And one function called process block that in this case does nothing, just clears the buffer. But I wanted to see if I can make something that, at least from the user's perspective, will have as little code as possible. But to do this, I needed this base class. And this base class is just something that just covered all the boilerplate that the plugin configuration has, save and load presets, declaring the number of programs, all these kind of stuff you usually have in the interface. And I brought it from a custom JUCE module that I made. Right, so it's a JUCE module that has that base class in there, and if I go in there, it will show that it's got a bunch of overrides on the JUCE audio processor class. Some of these are just like empty implementations because most of the time you don't even need the function to get some sound. So this is just something that I always use. I'm using this base class all over the code base. So I encapsulate it in a JUCE module. And I structured it along with the repo. So when I declare the repo, I just add the modules as a subdirectory. When I go in there, in the modules, I have something like add custom module tasks, share processing code, and share plugin helpers, like 3 different shared code libraries. And then when I go into one of the plugins, like this minimal plugin, all I have to do, just like we've seen before, is I link against it. So I can link against this thing, shared plugin helpers, along with JUCE and other JUCE things. So this, and the way, and now that I've done this, it's super easy. So now all over my code, or all over this repository, and soon you'll see even in other repositories, I will now have access to this code. I don't have to rewrite implementations of this very trivial base class, and I don't need to define complicated ways to link against it. I can just link against my custom module. It's right here. And something like my MIDI effects template, which would look almost exactly the same, also links against it. And then this, in the source code, it can do something like that. So now my MIDI effects template is almost as clean looking as the minimal template, right? So this was like a very quick way to just share stuff, right? You just you declare a module, and this module is now known to everybody who knows of your CMake project, or this library, really, right? And then you can just bring it in, you know, whenever you fancy some of your own code to be in there, just like you want to be using JUCE. So so this is like the basics of the setup. If you want to ever go in there, it's on my GitHub. You can observe these examples. You can build them. Hopefully, it will be trivial to just get to build. So, but not. There are actually more complicated situations. So let me close that. And okay, so one of the things I like to do is, you know what, once I've configured how JUCE builds with all the Mac flags and Windows flags and blah, 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 I don't want to do this again. I feel like I've found the best flags. Like, this is how I want to make JUCE apps. And I want to keep using those same configurations. So here, for example, I have another repo that I made. Oh, oops. Okay, so if I have another repo, and this is way more minimal because this just brings in the other repo, right? It just builds up on the previous one, and this will just bring all these configurations, and that's it. I can just go ahead and add my plugin subdirectory, which will just have a simple test plugin that can also use shared plugin helpers and use it in the code. So I've just passed along all this information to my next project, right? I can just share it. I don't have to copy paste code from projects. I don't have to use Git submodules that will require additional commands. This is in there. Another thing I've done here, which I haven't talked about a lot, but you can also define functions. So for example, I've found that this step here is actually common. I do this all the time. I always set the same compile definitions on a plugin. So you can just, like any programming language, you can define a function, right? Set default plugin with the name of the target, and then it will do these things to this plugin. So if I go to CMake, the CMake of the plugin, I just call this JUCE function to configure JUCE. I add the sources, and then I call set default plugin, and it will just add the default stuff, which will make it really easy for me when I start the next plugin, which will very likely have the exact same things in it. So so that's all good, but you don't always want to do what I just did, which is connect to GitHub, because GitHub might take a while fetching the things, but also you might actually want to be making changes to the dependency. If you have like a complicated repository with a shared library and another shared library and a few plugins, you might you want to be able to addition like library changes with your app changes. Like you want to test everything together and making sure that works. So what you can do in this case, I like to set up something I call a workspace, even though a workspace can also just be a command line, things you pass in the command line. But what I do is I define a CMake file that just sets a bunch of flags. This is just so that I will not have a very complicated command line to call. And all I do here is I tell the dependent repo that we've just seen. So I'm adding it here. But before I'm adding it, I'm just telling it where the source of JUCE and the source of the CMake repo will be. So instead of fetching it from somewhere in the universe, it's gonna go to my local drive, which will mean that I can now test like Git commits. I can bring in branches. I can make local changes. I can do anything that I locally do, and this thing will always know to resolve all these different dependencies, right? So I didn't have to set up a Git submodule command for this to happen. I didn't have to call some external package manager. CMake will know to resolve this, and whenever somebody else just grabs this repo without this workspace, without these two extra commands, then it will just go to GitHub and get the versions that are listed inside the actual repos. Like in this case of JUCE, it will be the develop branch. So this is what I do to set up I guess more complicated environments, because sometimes I will have a lot of these different repos that are dependent in each other. Some are mine, some are other developers, some are external. So this is a really nice way for me to configure an environment where I'm abusing everything. I can test forks and not be overwhelmed by the complexity. Okay, so one last thing before I'll finish this is unit tests. So this is something else that people really like to do, like unit test their code. So CMake makes it really easy to do unit tests. So here I said something like if build unit test. Build unit test is just some configuration flag that you can pass in. Do you want them or not? And then I added the tests in like a subdirectory. So the test directory did some configuration, but then it brought in catch2, which is my favorite testing framework, included it, and then it just built a JUCE console app so that I can run the tests in it. So it just builds a dummy app with almost nothing and links with catch2. And then catch2 has another really friendly CMake command called catch discover tests. So let's see if we can run the test, right? So in one of these targets that open up, I have something called a unit test runner. So let's run it. It's going to build and run, and all the tests pass. Let's see those tests. By the way, they're not very interesting. They're just checking that JUCE, JMin, and JMax are doing the exact same thing like the stud versions. So one test case tests the min version, one other test case tests the max version. So the cool bit is not only that you can run those manually in like a console app, CMake and CLion, by the way, too, will discover those tests because we've ran the catch discover test command. So for example, you can just call something like ctest, and you can see that it ran all the tests, right? So it does it even without knowing what your framework is. It kind of gets configured automatically with it. And if I'm using something like CLion, it gets even more advanced because CLion will detect that I have ctest configurations, and you can even do stuff like pick which tests you want to run. If you're debugging tests, you see, it just picked up the names without me having to write them into the IDE. So it's a very, very nice way to kind of integrate all your unit tests into the same workflow. Okay, that's it. Hopefully it wasn't too heavy. And if there's any questions, happy to answer.
Yeah, thank you so much, Eyal. That was amazing. That was very, very, very helpful. Just actually curious if you're aware of this. You go to CLion, there's also actually a way to run individual tests directly in there. You can just do the little green arrow next to the test, and it's gonna run it.
Yes,
and
absolutely.
things like
yes.
that. So there's like cool Catch and CLion integration going on. Actually, Catch is also my favorite testing framework. So yes. Yeah, we have a few questions. FF Audio is asking, does the GitHub repo need to be prepared for CPM? That's the CMake library we talked earlier about. Or is it just having a CMake list.txt?
It just needs a CMake list.txt. Like it will under the hood just bring it in and call add subdirectory or something on it. If it doesn't have it, like if it's just some other repo that doesn't have it, there's or if you don't want it, by the way, there's situations where it has a CMake list, but it does things that you don't care about. You want to do your own configuration. There's ways to configure this in CPM. Like if you go to their GitHub page, so there's a few like flags, like download only or stuff like that.
Cool. And I would like to piggyback on that question myself and actually comment on CPM. So I've actually never heard about it before. So it's essentially like a package manager for CMake, right?
Yeah.
Can you say again maybe where we can get it from? Like where is it available? Like the URL? Maybe we can later add it to the video description or something.
Yeah. It's just GitHub cpm.cmake. You can look for that. It's an open source, free to use library, and it essentially just wraps things that CMake already has, but it adds some extra bit of logic so that if you have a complicated chain of dependencies, then it knows how to resolve them, which pure CMake will need a bit of help if you just do. This kind of looks at your tree of stuff and says, oh, some library back deep in the tree search for this thing, and I can fetch it from the root, so I'll just fetch it once and not like a million times.
So that's really cool. Do you know how CPM compares to like other C++ package managers? For example, you're aware of Conan or things like that?
I'm not an expert on it. From my little experience with Conan, VC package, and some of the others. So first of all, CPM is a part of CMake, so nobody has to install it. So that to me was like the best advantage. Like if you call CMake -G your IDE, it's gonna work. Like you don't need to ask the user to install extra software, and like it's so that was like the first bit for me. I think Conan and other things in that field are more advanced. Like they do what this does and more, but they also require some infrastructure because you need to create Conan packages for everything. Like there's some setting up to do, which I'm not as well versed in. So
cool. Well, yeah, definitely learned something today. Thank you very much. We have one more question by Paul Davis, who's asking, JUCE requires some specific configuration to build plugins for Linux correctly. Can the technique in this template deal with that?
Yes, 100%. So for example, my repo hopefully has the right flags to build for Linux already. Like there's a few things that you have to like disable the web browser or something for it to build. But yes, and you can definitely, not only that you can do them, you can pass them and then, have one function that says configure Linux plugin the way you want it to, and just reuse that everywhere.
Okay, well, that's really cool. There's a follow-up question from FF Audio. Can you reference a certain hash in CPM, or is it always head?
Yes. You can pick a hash or a brand. Yeah. It's very, very much like most, NPM and other like package managers that have similar functionality.
Cool. And also I'm wondering, so using JUCE and using like JUCE's native CMake integration. So there's a project that I'm involved in where, before JUCE had CMake support, there was this other project called Fruit by Alan Martin. Have you used this? Do you know like how it kind of compares to like the new kind of JUCE CMake support that's kind of official?
Yeah, I've actually used it a bit. I was quite a bit actually before the native support was there. So Fruit is an amazing project, by the way. Shout out to Alain Martin, who's again one of my guides along the path of CMake. So his thing is actually was made first of all to take an existing producer project and just do an as-is conversion. And I think that the newest version of Fruit also generate a native JUCE 6 CMake instead of what it was before. But he can probably explain more on it. The best thing about what he does is that if you have an existing thing, you can get an exact translation of how your project has been before, which is important because sometimes changing the build settings, if they're not exactly the same, some weird problems could show up. So you want to make sure that you don't ruin your product by switching the build system.
Cool. Yeah. So it seems to me that CMake is very quickly becoming this thing that you just kind of have to know about if you work in the audio industry. I remember a big company that I worked at many years ago that I shall not name actually was not using it, and they had like an Xcode project and like a Visual Studio project, and every time you had to like add a new file, you had to like add it to the Xcode project and like start the PC, add it to the Visual Studio project, and you forget to do that, and everybody's projects break, and then they kind of migrated to CMake, and it was quite challenging because of the kind of size of the code base, but in the end, like really the only way to go. And ever since, like I've seen more and more and more companies and projects migrate to CMake, and whenever I do stuff, it's just because also I use C-Line, like I just start with CMake, and I think really this is the way to go. So thank you so much for introducing it so well, and especially with this kind of audio plugin focus, because I think this is kind of missing in some of the material that's kind of out there on this topic. So that's really cool. I'm going to wait for another second. If anybody else has questions to Eyal on the YouTube chat, please ask them now. All right. It doesn't seem like we have any. So again, thank you so much for the talk. It was really, really cool. And I think we all learned a lot about CMake today. All right. And I'm going to pass over to Josh.